Okay, now we're going to talk about product to sum formulas and sum to product formulas. And these are formulas that we can use again to simplify expressions, evaluate trig functions, and prove identities. So if you have a product of two trig functions and you want to write it as the sum or a difference of two trig functions, you can use some of the formulas in the first shaded blue box. And then if you have the sum or the difference of two trig functions and you want to write it as a product, you can use the formulas that are in the second shaded blue box. And the formulas in the second shaded blue box are derived from the formulas in the first blue box. And the product to sum formulas are derived actually from the sum and difference formulas that we talked about in a previous section. Okay, so the first example says write the product as a sum. So it's written as a product. We have sine of an angle times cosine of an angle. So I want to think of that 2x as u and that 3x as v. And I want to look above, and I want to find a formula where I have sine of u times cosine of v. So if I look above, the very first formula here is sine u cosine v. So I'm going to use the formula sine u cosine v is equal to 1/2, and then in brackets I have sine of u plus v plus sine of u minus v. So I have sine of 2x cosine of 3x is equal to 1/2 sine of u, which we said u is 2x, plus v, which is 3x, plus sine of u minus v. So u minus v would be 2x minus 3x. And I would get 1/2 sine of 5x plus sine of negative x. Now, I don't want to leave this with negative angles. So using my even and odd properties, I think back and since sine is an odd function, I know that sine of negative x is equal to negative sine x. So I'm going to erase this negative here and this plus, and I'm going to switch it. So this is coming from the fact that sine of negative x is equal to negative sine x using my properties of even and odd functions. Okay, the next example, think of 7x as u and 5x as v. And I want to find something that will work for sine u sine v. So if I look back up here, I want to write it as a sum. I have sine u sine v. So that's this formula right here, the last one. So I'm going to rewrite sine 7x, sine 5x as 1/2 cosine u minus v would be 7x minus 5x, which would be 2x, minus cosine of u plus v, so that's 7x plus 5x, which is 12x. So then I can multiply through the 4 and the 1/2, and I can rewrite this as 2 cosine 2x minus cosine 12x. The next example says find the value of the product of 2 sine of 52.5 times sine of 97.5. So if we think of u as 52.5 and v is 97.5, and I look back up here at my formula, I've sine u times sine v is 1/2 cosine u minus v minus cosine u plus v. So I have 2, and then I'm rewriting sine 52.5 times sine of 97.5 as 1/2 cosine of u minus v. U minus v would be negative 45 degrees. And then minus cosine u plus v. If I take 52.5 plus 97.5, that's going to give me 150 degrees. The 2 times the 1/2 give me 1. Cosine of negative 45 is the square root of 2 over 2. And cosine of 150 is negative square root of 3 over 2. So my final answer is going to be the square root of 2 plus the square root of 3 all over 2. Okay, now we have a sum or a difference, and we want to write it as a product. Now, if you look at the formula box above, we have the formula cosine of u minus cosine of v is equal to negative 2 times sine of u plus v all over 2 times sine of u minus v over 2. So if I look at the 9x as the u and the x as the v, we're going to rewrite cosine 9x minus cosine x as negative 2 sine of u plus v over 2. U is 9x, and when I add it to x, I get 10x. And then when I divide that by 2, I get 5x. So if u plus v, 9x plus x, which is 10, divide by 2 to get 5x. And then u minus v, which would be 9x minus x, which would be 8x, divided by 2 would give me 4x. So now we just wrote this sum as a product. Okay, in the next example, we're going to do the same thing. We're going to rewrite this sum as a product, and I'm going to think of this as u and this is v. If we look above, our formula is sine u plus sine v is equal to 2 sine of u plus v over 2 times cosine of u minus v over 2. Since u is 7x and v is x, I'm going to have sine of 4x because I take u plus v, which is 7x plus x, which is 8x, and divide by 2. And then u minus v is going to be 7x minus x, which is 6x. And when you divide that by 2, you get 3x. So here is my product, which is equivalent to this expression right here. Now let's use these formulas to prove identities. I'm going to take this right-hand side, and I'm going to use my sum and product formulas to show that it's equal to sine 8x. So I'm going to think of this as u and this is v, and I'm going to look above in my shaded blue box, and I'm going to look to see if there's a way I can write this as a sum or difference if I have sine of u times cosine of v. So I'm going to rewrite sine of u times cosine of v using our formula as 1/2 sine of u plus v, which would be 8x, plus sine of u minus v, 4x minus 4x would be 0. And I want to show that this is all equal to sine of 8x. The 2 and the 1/2, when I multiply those, I get 1. So these cross off. I'm left with sine 8x plus sine of 0. Sine of 0 is actually 0. So this crosses off, and I'm left with sine of 8x is equal to sine of 8x. So we're done with this identity. Okay, in the second identity, we've got to show that sine 3x plus sine 7x divided by cosine 3x minus 7x is equal to cotangent 2x. So I'm going to rewrite the numerator and the denominator, and I'm going to rewrite it using my sum to product formulas. I'm going to rewrite sine 3x plus sine of 7x as a product, and then I'm going to rewrite cosine 3x minus cosine 7x as a product. Now, if you look up in the second blue shaded box, I can rewrite sine of 3x plus sine of 7x as 2 sine of 5x cosine of negative 2x. And that is because I'm looking at this as my u and this is my v. So I'm going to take u plus v divided by 2, which will give me the 5x. And then I'm going to take the u minus v divided by 2. I got a little sloppy there. Let me fix it. Which will give me the negative 2x. Then, to rewrite the denominator, I'm going to use the formula where this is u and this is v. And I'm going to get negative 2 sine of 5x sine of negative 2x. And I want to show that that's all equal to cotangent of 2x. And I got this 5x because I took u plus v and divided by 2. And then I got the negative 2x because I took u minus v and divided by 2. Now, because cosine is an even function, if you recall, cosine of a negative angle, because it's even, is still equivalent to cosine of positive of that angle. So I'm going to rewrite the numerator as 2 sine 5x cosine 2x. I can do that because cosine is an even function. Okay, now in the denominator we have sine of negative 2x, and sine is an odd function, which means if I take sine of a negative angle, that's equal to negative sine of that angle. That's positive, the positive value of that angle. So I'm going to rewrite the denominator as positive 2 sine of 5x sine of 2x, because I take this negative out and I put it in front here, and when I put it in front here I get a double negative, which makes that negative 2 a positive 2. And now I can cross those off. I have sine of 5x over sine of 5x. I can cross those off, and I'm left with cosine of 2x over sine of 2x, and I want to show that that's equal to cotangent of 2x. And as you know, cosine over sine is cotangent, so this is equal to cotangent of 2x. And we are done. So you can use those sum and product formulas, just like all the other formulas that I showed you. You can use them to evaluate expressions, simplify expressions, evaluate trig functions, and prove identities.